Hey, this is Kelly, and this is my final project presentation, a book pairing system that will help you structure a more meaningful learning process. So what's the motivation of my project? Have you ever think of learning a new skill in your free time? For example, you're thinking oh, cybersecurity is really popular recently. Let me learn a new skill of cybersecurity. And you search for cybersecurity on the internet, and then boom, a bunch of books show up, and you don't know where to start. You don't know what books are for beginners, what's for advanced user, what are theory, and what are more practical ones. So these are where my idea came from. I want to build a system that will help the user to find the pairing styles they want and help them structure a more meaningful learning process. So first, for the data I use, I fetch all the books data from Google Books API. And to build a minimal viable product, this time I narrow down the topics to AI related. So the keywords I use are like artificial intelligence, natural language processes, or some of the AI related words to fetch the book data from Google Books API. And then next time I use Google Gemini to label this data, kind of replace the human label process. So for my system, I aim to provide two different kind of pairing style for the user. One is label, one is type. So for the label classification, I use Gemini to label all the books into either beginner books or advanced books. And for the type classification, I use Gemini to label them into theory or practice. For the evaluation metric, this time I use a more traditional and classical ways to evaluate my three approaches. So I use accuracy, which measures the overall correctness of the model. Precision, focus on the quality of positive predictions, and recall, evaluate the model ability to find all relevant instances. And also the F1 score is a harmonic mean of precision and recall. And for the label classification, across all three different approaches, I all label a beginner as 0, advanced and 1s. And for type classification, I label theory as 0, practice as 1. So these are a binary classification. So first is the naive approach. The way I do it is for the label classification, I define some keywords for beginners. So the keywords are including like beginner, easy, introduction, or like basic. So if we found these keywords in the description of the book, we would define it as beginner books. Otherwise, we would define it as an advanced book. And for the classification, I also define some keywords. So for the theory books, I define the keywords as some like theory, conceptual, fundamental. So if we found these words in the book's description, we would define it as a theory books. Otherwise, it would be a practice books. And this is the results of the naive approach. So we can see all the results of precision, recall, and F1 score. And for the accuracy, the label classification achieved a 0.57 accuracy. For type classification, there is a 0.47 accuracy. The second approach is classical machine learning model. So the process of training a model is first we load the data and then we use TF-IDF to vectorize all the book description. And then the third step, we also map the labels into 0 and 1 for both label classification and type classification. And then we train a random forest classifier. I split the data into 80% of training and 20% of testing. And I use Research CV to do the hyperparameters tuning. So these are the results of my classical machine learning models. The accuracy of label classification is 0.74, and the accuracy for type classification is 0.75. And the last approach is deep learning. So for the deep learning model, the first step is the same. We load the data, and then I use BERT tokenizer to tokenize the book description, and then load the pre-trained model of BERT. and I fine-tuned the BERT model based on a BERT based on cast. The reason I chose BERT based on cast is because this is basically a model pre-trained on a large data set of English books and Wikipedia. So this aligns with the goal of this project. And these are the results of the deep learning. The accuracy of label classification is 0.72, and the accuracy for type classification is 0.79. And these are the overall results. So for the label classification, the classical machine learning model achieved the highest accuracy. And for type classification, the deep learning approach performs the best. And then now is the demo time. So how this demo work? First, the user will input the topic they were interested in. So for example, I input NLP and I would choose a pairing style I like. And how this demo works is first the user will input a topic and this system will fetch the book from Google API at real time. So it will use the topic the user input in to find the related books. But other than that, I also implemented semantic search in my system. So how Google API find books is only based on the topic of the book. So it will try to find the books that have NLP in their topic. However, I also implemented semantic search, so it would encode the description of these books and calculate the cosine similarity to make sure that based on the book description, this book is really related to the topic the user inputs in. So the system will keep top 30 books that had the highest similarity score. And then after that, based on the pairing style the user choose, the system will predict the labels for this book and then recommend the 3 books from each category. So we can see there are 3 books for NLP theory and 3 NLP books for practical files. And there are also would have a link of these books. They can let the user get to the Google Books website and see more detail about these books. So the results of this final project is that for the label classification, classical ML achieve highest accuracy, and for type classification, deep learning approach has highest accuracy. And for the demo, adding semantic search help us find the most relevant books other than only matching the keywords on the book title. And what's a possible next step of this project is we can definitely get more training data and broaden the fields. As I mentioned earlier, now I only narrowed down the field to AI related, but we can definitely broaden the fields and also add more pairing style. That means train more data, train more models, and the user will have more pairing styles they can choose from. And this is the ethics statement of this project. So this project does not involve any human subjects, personal data, or sensitive information. And all book data I use are publicly available online. Efforts were made to ensure fair and unbiased recommendation, but because of the limitation of the training data, the model may occasionally reflect bias present in the training data, but we are committed to transparency and continuous improvement. Thank you.